So here's the robot from the top down, and what I'd like to do is get rid of this joint here. It's a bit fiddly because the purpose of having that joint there is so you can adjust the length of this arm to get the belt tension right. However, it's a bit of a pain in the butt because it doesn't only move on one axis. You can easily, when you're tightening that down, if you're not careful, bend the arm upwards and downwards, which means that this arm can then hit this part. If I turn it sideways a little bit, this arm here can get warped by the belt tension if you do it up too tight, or if you're not holding it flat when you do up that screw, then you can sort of lock it into a bent sort of attitude, which is bad because it throws other stuff out of alignment. And it's also a bit fiddly to get that done up because there's a lock nut on the bottom which you've got to hold with pliers and also with an Allen key or a driver or something tighten up that bolt, and it's hard to maintain the stretch on that arm. What I've done is I've done it up most of the way, sort of a bit harder than finger tight, with enough looseness in there to be able to sort of stretch the arm into the right length, and there's enough tension there to hold it there against the force of the belt trying to squish it back together. And then once I've got it clocked correctly and bent right, then I tighten it up. It's not too hard, it's not the end of the world, and if I can't think of a better option, then I'll probably just go with that. But I want to explore some different ideas for belt tensioning that would let me have a fixed length arm. And so when you're scouting up the design for all the different bits and bobs, you'd plug in the length of your arm to belt loop, and it would tell you need to make your arms this length. At the moment they're 95 millimeters, but with this belt it's actually like 94.2 or something like that. You'll notice if this one goes to center, it's slightly past center, so the two arms are not exactly the correct length. Is it going to do it? No, never mind. I could turn the power off. So I'm looking at different options for tensioning that belt. So if we draw like a crude image of it there, and we've got the belt going around like so. We need something to add some stretchitude to this belt. So we've got a couple options, but I'm trying to, throughout the entire design, only use 608 skate bearings because they are cheap and ubiquitous, and I don't want to have a diversity of belt types. So one potential option is to make the arm longer, make it wider. So right now I've got a 10 millimeter neck on the arm. This here is 10 mil, but there's no reason for that to be the case other than just keeping the mass down. And so what I could do is put a slot, a diagonal slot near the center, and then have a bolt that goes vertically through that slot that holds a bearing there. Probably would have made more sense had I done this to scale. And then over here, pretty rough, but you get the idea. Still a bit of factory schmoo on these bearings. So if I make a diagonal slot here and then bolt a bearing down on top, I can move this bearing in and out. Actually, it doesn't need to be diagonal, does it? It can just be straight across. But if I have this bolt, and I can move this bearing out until the correct belt tension is reached, and then crank it down to lock it in place. Now that would give us some static tension on the belt, which is better than nothing. But in the ideal case, you'd have dynamic tension. Like this would be on some kind of spring that would, this is a pushing out spring, if you can't tell. I can't tell. Anyway, such that if the belt loosens over time or if something bends, this bearing is being pushed out under spring force. So it will keep a relatively constant amount of tension on that belt, no matter what's going on with the overall mechanical design. However, I can't think of a neat way of getting a spring in there without adding a bunch of extra bulk to the dimensions of the design. So one relatively easy to come by form of spring is a street sweeper bristle or a wiper blade insert. So these are inside windscreen wipers on cars. They're easy to come by. Every car's got them inside. You just peel off the rubber and hey presto, you've got a nice bit of stainless steel. So I could work out some arrangement whereby this was bent like that and we have a post here and a post here, and they sit up against those posts and that acts to push the bearing out against the belt. That could work quite well, or I could build a little holder for the bearing and then just have the wiper blade or the spring fixed on one side, and it will act to force it out there. But a lot of these designs, so if I look at the arm side on, so here's the stack of bearings, and then here's the wood, and here's the other stack of bearings stacked up this ways. A lot of these are going to result in an extra height. So if I have a bearing sitting up the top of there, I need a washer to stop it rubbing on the arm, so that adds a bit of height. Then we add the bearing, which adds some more height, and then there's something that needs to go on the top to fix it on, and then there needs to be a bolt that goes all the way through, and then a nut on this end. So this extra height here is at a premium, because if I, let me just knock the power out of this, every bit of height I add to the arm there, above this distance here, means that this stack needs to be higher in order to clear the arm. So if I have a bearing here to add the tension, it's not too bad, but then if I want to add a nut that retains that in, let me check this makes sense on the camera, yeah. If I have a bolt that goes down through there that needs to hold that down, then it's going to sit up considerably higher and I'll need to make this higher. And I want to try to keep this overall stack as low as possible, such that the enclosure as a whole can be not super duper tall. So this has got an 8mm inside diameter, and if I have a 8mm bolt running the whole way through, that 8mm bolt is going to have a pretty thick head on it. It's going to add about an extra at least 4 or 5mm on top of here, and then there's plus the 7, I think. So let's say 4, 7, one for the washer, and I'll need another washer in there. So we're looking at adding 13mm to the height above the arm here in total, which ain't nothing. That's probably too much if I'm being honest. Got a couple of other options for retaining this that don't have anything sitting proud at the top of the bearing. I could laser cut a little 8mm circle, like a sized washer that fits down inside there, and then use my smaller M3 or M2.5 bolts that I'm using elsewhere in the design, such that the head, like if this is the bearing drawn mega scale, we have our plywood washer down in here, and then we have the head of the bolt there, and then we torque this down. That goes through the arm. We torque this one down, and we squish this piece of wood here. We squish it in, and that flares it out, and that locks the bearing in place. However, getting the tolerances right on this piece of wood is going to be pretty hard. I can cut a piece of wood reasonably accurately to go in there, but in order for its minimum dimensions to be able to fit in there, and then its maximum dimensions lets it fit, but its minimum dimensions aren't so small, there's not so much clearance here that it can't be squished to lock it in place. That would let us get rid of those two, just be the height of the bearing and the washer. But even then, that's still a reasonable amount of height. I mean, ideally, we'd want to sneak it down in under under the existing height of every other component. So as it stands, just the bearing is too high. And bear in mind that any height I add to this has to be in multiples of 2.8 millimeters. That's the thickness of the plywood. Nominally 3 mil, but you know, there's variations. So I'd have to add a whole nother stack of plywood on top of there to give clearance for this idler bearing. Now it might be worth, in this case, having a different flavour of bearing. I've got a bunch of, I think 624s, smaller bearings that have like a 12 mil outside and a 5 mil inside or something like that. But as I said before, wherever possible, I'd like to keep it consistent, like a small diversity of parts required to build, because then you order those and you have all you need. But yeah, so other options could be a bit less elegant, just using some spring steel and having it like right up against the outside of the belt in some way, but that will add a lot of wear and tear to the belt and make it wear out faster. A lot of rep wrap designs use a closed peg spring as a tensioning mechanism, and they just sort of pinch on the side of the belt, and that works fine where the belt doesn't have to go around a pulley. That can't cleanly ride around a pulley without causing damage to the pulley and the belt. So it's not exactly straightforward. One thing I definitely want to do is make this arm wider, because there's no real reason for it to be this thin, and that would give us more rigidity on the flexing this way business. That might solve enough of the problem to make this flavour of arm tensioning, belt tensioning mechanism fine. Don't know. I think this might just be the least bad all round, but I'll continue to think about various options for even just static pressure, like locking a bearing at some point, to add some tension that holds it. Would be better than nothing. Anyway.